Okay, this video goes out to Jenna in block 3. This is your final review, and I'm just going to go through the problems as if you were doing them. So the first one is just combining like terms. It is 6x squared plus 3x. Now be careful, subtract every single term inside the quantity. When you do that, the signs will change because you're subtracting negatives. So I underline the ones that are similar. 6x squared minus 2x squared is 4x squared. 3x, 2x is a 5x, and then plus 12. Okay, number 2, these all say simplify, so we're not solving, we're just cleaning it up. These look like they can cancel, but they're different. So if I had this 2 become negative and this become positive, that would work. So I'm going to remove a negative so I can make this negative and then positive. So I'm allowed to do that as long as it gives me what I originally had. So if I had negative 4x times a negative 2x, that would be the same thing as 4x times 2x. If I had negative 4x times a 3y, it would be the same thing. So I just removed a negative 1, and I can do that as long as this is negative. So now we have a negative 2x, a positive 3y, negative 2x, positive 3y, and they cancel, or turn into 1, I should say. And you're just left with negative 4x. If you have to pause or rewind that, okay, go ahead. So obviously there's one like that on your final, okay, so make sure you know how to do that. Number 3, combine like terms. Are there any other mn cubed? No. Are there any other m squared n's? No. Are there any other m cubed n squareds? No. If there were, you would combine them. So that's it. That's your answer. You can't simplify it anymore. Number 4, it's going to be long division. Or factor if you can, but let's just use long division because I'm not sure if it's factorable. X to the 4th, x to the 3rd. There's nothing x squared, so we're going to make it 0. A positive 1x, and there's no constant. Okay, so x squared goes in x to the 4th twice, so I need 2 more x's. When you go back and distribute, you'll get x to the 4th plus 3x to the 3rd plus negative 5x squared. So realize if there's not a placeholder, you need to create one in descending order. You look at the first term, you look at the first term, and ask yourself, how does this get into this? Okay, so when we subtract, notice I put parentheses around the entire quantity. X to the 4th cancel. 4 minus 3 is 1x cubed. 0 minus minus is going to be a positive. And then bring 1 down because there's 3 here and I have 3 here. Okay, now I look at x cubed and I have x squared. I need an x. So x times x squared is x cubed. X times 3x is 3x squared. X times negative 5 is negative 5x. X's cancel. 5 minus 3 is 2. 1 minus minus 5 is 6. Bring down the 0. How do you get from x squared to 2x squared? You need a 2. So when you do that, you're going to get 2x squared, 6x, and negative 10. So factoring wouldn't have worked because we have a remainder. So 2x squareds cancel, 6x's cancel, 10 minus a negative 10 is a positive 10 that still needs to be divided by x squared plus 3x minus 5. So your answer is x squared plus x plus 2 plus the 10 that still needs to be divided by x squared plus 3x minus 5. The end. Okay, next one, you're combining like terms. So there's no other 2m cubes. There is negative 6 and a positive 2. There's a negative m and a negative 6m and a negative 1. Number 6, you have a power raised to a power that you have to take care of first before you multiply across. So be careful that negative 3 technically has an exponent of 1. So it's all going to be powers raised to powers. So we have negative 3 cubed, x to the 12th, y to the 6th, times 4x squared, y to the 10. Negative 3 cubed is negative 3 times negative 3, 9, negative 3, 20, negative 27. So I'm just going to rewrite it. Okay, negative 27, I'm just going to do it down here real quick. Negative 27 times 4 is 28, carry the 2. 4 times 2 is 8. 8 plus 2 is 10. So negative 108 is what we're going to have. When we multiply, x, we have 14 x's, y to the 16th. Okay, this is going to be same thing, power raised to a power, 5 to the negative 3rd, x to the 21st, y to the 6th, all over 10 to the negative 3rd, x to the negative, well, no, it's positive, 30th, y to the negative 12th. Before I subtract or simplify, let's just move things. If you have a negative exponent, it gets moved to the opposite side. Positive stays, positive exponent stays. Moves, stays, goes. So I like to move everything first, keep it positive. So 10 to the 3rd is 10 times 10 times 10. Okay, 5 to the 3rd is 5 times 5 times 5. There's 21 x's up here and there's 30 down here. So that means that there's 9 more on the bottom. 30 minus 21. I have 6 and I have 12, so it's 18. Okay, so you can simplify this in your calculator, but I know that I had a 10 times 10 times 10, and I had a 5 times 5 times 5. When that simplifies, you get a 2, a 2, and a 2 left over, 10 divided by 5. So really on top, it should be 8 left over. And if you're like, what did you just say? Ignore that and just put this in your calculator, divide it. Remember, you can always pause and go back. I really encourage you to try as much as you can on your own before watching me so that you have a familiarity with each problem. So the next one, you need to factor before you simplify. Difference of two perfect squares. X plus 3, x minus 3. The bottom, you have 3 terms. You don't have a plus in the back. So one's going to be positive, one's going to be negative. It doesn't matter which one comes first. What are factors of 3 that add to 2? Well, it's only 3 and 1. So a negative 3 and a positive 1 will give you a negative 2. And always FOIL to check your work. X times x is x squared. X times negative 3 is negative 3x, positive 1x. All right, what simplifies? And then 3 can go into 9 3 times. So it's down to 1/3. You can write the 1. You don't have to. I would just write x plus 3 all over 3 times the quantity x plus 1. And some people are like, oh, can you leave it like that? Can you put it back? Well, your final is going to be multiple choice. So if this is your answer, pick that one. If you see the answer is this, then pick that one. It just depends on what's given to you. I don't care which one you give me. All right, the next one, try cleaning it up as you go. 4x minus 6. Is there a GCF? Yes, 2. The top, is there a GCF on the other one? Yeah, take out a 3. On the bottom, here's the thing. You're like, ugh, I'm not good with the ones where the numbers are in front. Here's a hint. Look at this one. There's probably going to be a 2x minus 3 if there's 2x here. So you know the probably should be 2x minus 3. All right, well, what's the other piece we need to get that trinomial? Well, if I have 2x, I know the other one has to be 1x. And if there's a 3 in the back, it's got to be a 3 and a 1. So if there's 3 here, I know this one's a 3, then the other one's got to be 1. So it's just kind of a guess and check game. Logic and reasoning. Since it's a negative 3 in the back, and I have negative 3, this has got to be positive 1. So kind of work backwards and break down. Okay, I see a 2x minus 3 on top. It's probably on the bottom. All right, so we can break this down. And then these 3's cancel. And you have 2 times the quantity x squared minus 1 over x times the quantity x plus 1. Some of you would get this on the final and go, my answer is not here, because you can keep breaking it down. I just didn't want to overwhelm you. Well, it's the difference of 2 perfect squares again. X plus 1, x minus 1. So your final answer is 2 times the quantity x minus 1 all over x. You can distribute it. You can leave it like that. If I said on your final, it's going to be multiple choice. All right, this one, there's a GCF on top. 5 times the quantity x squared minus 4. And on the bottom, and you're like, wait, Miss Caserta, you can keep factoring. I'll get there. On the bottom, you have 3 terms with a plus in the back. So this sign will appear twice. So it's going to be x minus x minus. So that 4, what are factors of 4 that give you 4? 2 and 2. All right, well, we never kept factoring the top, which is the difference of 2 perfect squares. So this goes away, and then this is your answer. Now, so take out a GCF, difference of 2 perfect squares, factor this, those cancel. That's your answer. If you want to put the 5 back in, great. Doesn't matter to me. All right, number 11. Can we factor the left side? Sure. 2g minus 6, you take out a GCF. The bottom is what it is. When you divide by a fraction, you're really multiplying by the reciprocal. I'm not going to go crazy and factor just yet. I'm going to rewrite it and take my time so that I don't make any mistakes. So I flip it. So take it slow, take it one step at a time. Don't try to do 3 things at once. Now start factoring. The top has a GCF. The bottom is a trinomial. So one's going to be positive, one's going to be negative, or vice versa. Factors of 6 that give you a 1 are 2 and 3. It's got to be a negative 3 and a positive 2. because you want those two numbers to give you a -1. So take a second. Now, the g plus 2's are going to cancel. The g minus 3's are going to cancel. The h squareds are going to cancel. The 2's, I shouldn't say cancel. It's horrible when you say. They don't cancel. They turn to a 1. They simplify to a 1. There's nothing on top here. So it's 1. That's why I said it doesn't cancel. And g's on the bottom. 1 over g. All right. Number 12. Technically, this is a 2. We don't write 2 here ever, but when there's a cube root, there's a 3. When there's a fifth root, there's a 5. So when there's a square root, there's technically a 2. This is being raised to the fourth. You could essentially say this is this. So your answer is this. If you want to write out 4 of these and take pairs, you can, or you can just leave it like that. The next one is a cube root. I'll write this one out. I like to yank -1 over here and say, okay, 27 is 3, 3, 3, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, do you have to do this? No, but I'm just showing you both ways. Cube root. So we have a 3, take it out. We have to have groups of 3. 3m's, 3m's, so it's m squared. 3y's, 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 3y's. 1, 2, 3, 4, 5. And there's a cube root of m left. Okay, but what about that negative? Well, if you go on your calculator to the math button, you can just take the cube root of -1 and logically know that -1 times -1 times -1 is -1. Or if you type that in your math in your calculator, they'll give you -1. So your answer should be -3. Because we forgot about that -1. And the next one, you're foiling. You have 2 terms and 2 terms. 2 times 3 is 6. 2 times -3 root 4 is -6 root 4. The whole numbers go with the whole numbers. A radical goes with a radical. 2 times 3. And then 3 times root 4 is 3 root 4. And root 4 times -3 root 4 is -3 root 16. The numbers inside go together. Now we can clean it up. 6 minus 6 times 2 plus 3 times 2 minus 3 times 4. 6 minus 12 plus 6 minus 12 is -6 plus -6. Yeah, that's right. Okay. Is -12. All right, number 15, taking something to a half power is the same as saying square root. Same thing. And if there's a square root on top and a square root on the bottom, it's just one big fat square root. So we can clean up the inside first and make it a 14, an m to the 5th, and an n to the 6th. And when you do that, you're going to get 2, 7, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And take your pairs out. Can't take a 2, can't take a 7, take an M, take an M, take an N, take an N, take an N. So M squared, N to the third, 14M. 16 wants you to rationalize because the denominator is irrational. It's a square root that never ends. So when they want you to rationalize, they want you to get rid of a radical in the denominator. Unfortunately, this is connected to a positive 1. So we need to multiply what's called its conjugate, which is -5 minus 1. And what you do to the bottom, you must do to the top. Anything divided by itself is 1. So we're not really changing it. We're just giving it a makeover. Okay. So it's 3 times the quantity, -5, or root 5 minus 1. And if you FOIL the bottom, you should get 5 minus root 5 plus root 5 minus 1. So it ends up being 3 times the quantity, root 5 minus 1. I like to distribute at the end in case things can cancel. Middle terms, 5 minus 1, which is 4. So you could leave it like this, or you could write it like this. Like I said, doesn't matter. It just depends on what your final says is the answer. All right, 17 is x to the third, fourth root. Okay, x to the third, fourth root. Describe the end behavior. Here, it's x squared, but it's negative, so it flips. Both ends are heading towards negative infinity. So you say, as x approaches positive infinity, what is f of x doing? And as x approaches negative infinity, what is f of x doing? Okay, so as I get closer to positive numbers, as x gets bigger this way, it's still going down. And as x gets bigger negatively, it's going down. So here, we said x cubed is like the Loch Ness Monster. Okay, as x gets bigger, it's getting taller. As x gets smaller, it's going negative. So as x approaches positive infinity, as x goes to 1, 2, 3, 4, your outputs are getting bigger and bigger. And as x approaches negative infinity, so does your outputs. It's going down. All right, the last one says growth or decay. Growth, this is 300%. Growth, that's 400%. Growth, 1.3, okay, which actually is a 30% growth. Here, 88% remains, so it was a 12% decay. You don't have to say that, but I'm just trying to explain it to you. If it's greater than 1, it's over 100%, which means it's growing. Okay, that was first page. All right. 20. Solve for x. Okay, here's the thing. If you didn't know how to do 20a and b, it's multiple choice. You can just plug in your answers and see if they work. Well, we have a denominator of x squared. So that means I have to multiply the numerator by x squared to get rid of that denominator. So we have x squared plus 4x squared over x equals 12x squared over x squared. This is what's called clearing the denominator. We're getting rid of it. We're like, you're ugly. We need to make you pretty so we can solve way easier, which we're doing. Now this is a lot easier to solve. You got to bring everything to one side and factor and solve from there. So what are factors of 12 that give you 4? Is that possible? Do we need to use a quadratic formula? Well, we have 3 terms with a minus in the back, so the signs are going to be opposite. Factors of 12 are 4 and 3. Nope. Factors of 12 are 6 and 2. Yep. You set each piece equal to 0 when you solve. Okay, and plug them back in just to make sure, and they will work. So 6, negative 6 and 2. Okay, here, my denominators are x, x plus 2, and x times x plus 2. So if I multiply all the numerators by x times x plus 2, the denominators will disappear. Multiply to that numerator. Multiply to this numerator. Let's do that. Sure. Multiply it to all the numerators. Once you do that, these will cancel. I'm sorry, turn to 1. Simplify. Simplify. 7x is left. Simplify. 14 is left. So you're giving it a makeover before you even do anything. Now, you got to simplify and clean up all that stuff. So you can solve. 3x, 2x is 5x. Oops, I forgot about that 7. 5, 7 is 2. Oh, we got 14 we need to bring to the other side. Okay, what are factors of 8 that give you 2? So one's going to be a positive, one's going to be a negative. Factors of 8 are 4 and 2. Does that give you 2? Yep. So let's do negative 4 and a positive 2. So x squared, yes. 2x, negative, yep. Okay, so solve. Now, they should work, but if I put 4 as a denominator here, nothing bad's going to happen. If I put negative 2 as a denominator here, what happens? 0. It doesn't work. So this is an extraneous solution. Be careful, this one might trick you on your test. Okay. All right, negative 2 won't work because it'll make your denominator 0. Part C. They want you to solve for x. So I need to get x by itself, get rid of the square root, get rid of the 2, get rid of the 3. Okay. Get rid of the roof. Raise the roof. Square it. So you square it, you add 2, divide by 3. Make sure you put 9 back in to see if it works. 27 minus 2 is 25. Yep, it works. Part D, this is saying 3 to the 4th gives you x. Change from log to exponential. X is going to be 9 times 9 or 81. 21. What is the domain? Your domain is, well, we can't have anything negative here. We can't have anything negative under here. So we have to say whatever is under here, called the radicand, has to be greater than or equal to 0. When you do that, you get the square root of 8. Now here's the hard part. You put a quadratic under a radical. So it can't really work like this. We're just here to get the critical number, it's called, the square root of 8. So the square root of 8 is 2 root 2. So you're going to have intervals. Because really, you're saying, okay, from negative infinity to negative square root of 8, from negative square root of 8 to square root of 8, or square root of 8 to infinity are your choices. Because you have 2 numbers here. So it can't be all real numbers. It stops at these specific points. So pick a number in between each interval and see if it works. I like to go with 0. 0 isn't here. Does 0 work? Let's put 0 in here. Does this work? No. So it's not this interval. Square root of 8 is like 2 something. So let's try the number 5. You can pick any number you want. Does 5 work in here? 5 squared minus 8. 25 minus 8. Can you get the square root of 17? Yeah, that's possible. So this interval works. Here, let's try negative 5. If I put negative 5 in, I'll get the same thing. So these two intervals are your domain. It's almost all real numbers, but it's not. These two numbers are your critical numbers. So this is your answer. Okay, you can use a note card on your final. I always let the kids use a 5x7. Okay, so what I would do if I were you is I would do this midterm. Ones you know, don't put on the note card. Kids always are like, I want to put everything I know on the note card. They're like, y equals mx plus b. Put on the problems you don't understand. I would put examples. I wouldn't put formulas. Okay, so if that's not something you don't understand, put it on your card. Here, you have to factor. Okay, now I can clearly see my denominator. Domain's tricky. The domain is usually all real numbers, except when are we going to run into errors? Well, here you had to think about it. Negatives. When are we going to run into errors? When we divide by 0. So what number would make me get a 0, a -2, a -3? So the domain here is all real numbers. X cannot equal -2. X cannot equal -3. And the notation might be different on your final, but as long as you can see this, you're good. It doesn't matter that these can cancel out. They want to know if with your original function, what can't you use? All right, this one is a little tricky. It's not in slope-intercept form. It's not in a y equals form. So get it to where it's y equals. So get it to where y is by itself. Okay, now you can do it. So the first thing you did was multiply by -5/2 and subtract 6. So the inverse would be add 6 and multiply the whole thing by -2/5. So that could be your answer, or this could be your answer. If you're like, huh? Well, if that doesn't make sense to you, logic, undoing, then use the other method, which we'll do here. This method is saying, okay, inverses are vice versa. So switch x and y and solve for y. We divided by 2. Now we're going to multiply by 2. We subtracted 1. Now we're going to add 1. We multiplied by 7. Now we're going to divide by 7. That's the inverse. Another way is if you weren't sure, take a number and plug it in. If I plug in 2, I'll get 6.5. Then take 6.5, put it in the inverse, I should get 2. So again, if that one's a tricky one for you, write that one down. All right. Hang in there. Or feel free to take a break and come back another day. 23. Given these two functions, find the following functions. They want you to put a y plus 2 in for x. So wherever you see an x, you're going to replace it with a y plus 2. That could be your answer, but probably not. They're probably going to FOIL when they square it. You will get y squared plus 4y plus 4. Let's move this up to the top. We don't got much room. So remember, when you square something, you're foiling it. Foil and then bring in the 3. Okay? What's up? This one, it shouldn't be cubed. It should be cubed, I mean, because this 3 comes up here. So that should be cubed. I don't know how you got from here to here, because where did that 3 go? That 3 needs to go back to the x, and then you divide that. Okay, I'm making a video. Just give me a little bit, okay? Sorry. Okay. G of f of x. So, you're going to put f of x inside of g. You're going to put f of x inside of g. So it's going to be x minus 2 or 3x squared plus 1 minus 2, which is 3x squared minus 1. This one, you're taking g of x and you're putting it in for x. So it's not 3x squared plus 1 anymore. It's 3 something squared plus 1. Well, what is it? X minus 2. Now you could keep x minus 2 in there, or you could just FOIL it. You don't have to, but it depends what your answer. If you don't have this answer on your test, then you have to FOIL it. This one, you're putting negative 2 in for f. So 3 negative 2 squared plus 1 is 3 times 4 plus 1. 12 plus 1, 13. Then you're taking that 13 and putting it into g. 13 minus 2, which is 11. Okay. I'm going to do sequences and series last because that was our last one to do. Let's see if we have any probability. Okay. Probability. You go to a Subway and there's 6 types of breads, 7 choices of meat, 5 types of cheese, and 10 different dressings. You choose one of each. How many different combinations? So if people get confused, like, how do you know it's combinations? No, if it's saying you choose one of each, you can do it like this, or you can do, I'm choosing one. I'm choosing one. It says you choose one of each. I am choosing, I mean, that's totally up to you. Either, this is the same thing either way. So it's going to be 42 and 50. And whatever that is, that's what that is. I'm going to grab a calculator. $2,100? Okay, thank you. Okay. Bob has 10 friends. He invites them to sit around a 70-inch round table. Okay. So the 70-inch part isn't the part you're supposed to pay attention to. It's that it's round. So it's not linear permutation. It's round. So if he has 10 friends, we know with permutations that are circular, you subtract 1. And that's your answer. But why? So 9, hit the math button, go over to probability, is 362,880. Because if I have 10 people at this table and I keep turning the table around, it's still the same order, no matter what person's sitting right here in front of me. It's still the same order. So you have to remove in the 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Those 10 options really aren't distinct. So that's why it's minus 1. All right, 36. A number cube is rolled twice. Find the probability of rolling a 1 or 2 and then an even number. So if you roll a 1 or a 2, that is 2 options out of 6. And then, comma, is multiplication, fundamental counting principle. An even number is a 2, a 4, or a 6. So that's 3 out of 6 options, which is 6 over 6 times 6, which reduces to a 6. Number 37. Are the events independent or dependent? Jake pulls a card out of a deck, independent, and puts it back and pulls out another card, independent. Because he put it back, they don't have an effect on each other. So you might get a question like this and you're just supposed to say independent. What's the probability of pulling out a 52 card deck and getting an ace if someone had pulled out an ace earlier? So what's the probability of getting an ace given that an ace was pulled? So I used to have 4, but now I have 3 aces. I used to have 52, and now I have 51. A toy box contains 8 toys. What's the probability of picking out a doll and then a bear? We're assuming there's only one of each. So we had 1 out of 8 and then 1 out of 7. Really, we should say, what's the probability of getting a doll and then a bear given that we got a doll? It doesn't matter how you notate it. It's 1 out of 56. Okay, now let's go back to sequences and series. So it's pretty big here because normally when I give the test, this is the review packet for the test as well. It says, write the next 4 terms of a sequence. So it tells you your first term is 30. And every time you're going to take the previous term, multiply it by half, and add 3. So at whatever nth term we're finding, we're taking the n minus 1 term. So if I'm finding term 1, we know it's 30. They want you to find term 2, term 3, term 4, and term 5. Those are the next 4 terms. So if I'm taking term 2, I'm taking the one before it, 30, multiplying it by a half, and adding 3. 15 plus 3 is 18. The next one, I'm taking a half times the previous term and adding 3. 9 plus 3, 12. So for term 4, I'm taking the previous term, 12, adding 3. So it's going to be 6 plus 3, which is 9. I'm taking the previous term, multiplying it by a half, and adding 3. Half of 9 is 4.5, plus 3 is 7.5. So that's it. This is called a recursive formula. It's like reoccurring. Taking the previous, taking the previous, taking the previous, okay? This one's saying, what is the value of this? This symbol here is called a summation. It says you're going to put in 1, 2, 3, 4, all the way up to 6, and then add them up. So if I put 1 in here, 1 squared minus 5, that's a negative 4. Then I'm going to put 2 in here. Then I'm going to put 3 in here. Then I'm going to put 4 in here. Then I'm going to put 5 in here. Then I'm going to put 6 in here. When I add them all up, I'm going to get 10, 30, 61. So 1 minus 5, let's make sure. 1 minus 5 is negative 4. Negative 1, 4, 11, 20, yes. 20, 51, 61, 62. Yep, okay. It says for the arithmetic. Well, arithmetic means that they just have a pattern in between that is the same. Like they're adding 2, they're adding 2. You want to know the sum of adding the first 10 terms. So you could think of it like this. This is your first term, second term, fourth term, fifth term, sixth term, seventh term, eighth term, ninth term, 10th term. You could do it like that, or you could figure it out another way, where you take your first term, you add it to your last term. You're going to get 38. 13 and 25 is 38. 15 and 23, 38. 17 and 20, you can keep going like that. So there's a formula for that, or you can just straight up add them together. The formula is however many numbers you have, divide it by 2, and take the first term and add it to the last term. So I'm just kind of giving you a quick lesson. You could legit say, I don't feel like learning this, and just add up all the numbers. You do not have to. Well, you have 10 numbers because it said we're going to add up 10 numbers. Your first term's 11. What is your last term? Okay. Your last term is always your first term plus your common difference of 2 n minus 1 times. Well, 10 minus 1, 9 times. So how many times are you adding that to? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So your last term should be 29. Oh, that's why I forgot it. 29. So your first term's 11, your last term's 29. That's why this was off. Ignore what I said earlier. So 5 times, this is going to be 30, 40. Your answer should be 200. So if I went to calculator, I remember doing this when I was your age at McDowell for SATs. I would have forgot this whole formula, but we could have done this. 1 number, 2 numbers, 3 numbers, 4 numbers, 5 numbers, 6 numbers, 7 numbers, 8 numbers, 9 numbers, 10 numbers, 200. You could do it that way. Okay. All right. This one says find 3 arithmetic means between 5 and 17. That's 1 jump, 2 jump, 3 jump, 4 jumps. So if I start with a number 5, I'm going to have the same common differences. I'm going to have 4 of them to end up with 17. I'm going to subtract 5 from both sides, divide by 4, and understand that the jump to each number had to be 3. So the 3 numbers, or it's called means in between, would be 8, 11, jump to here, 14. This better be a jump of 3. Yep. So you start with your first number. How many jumps do you have to make to get to the end? And then that's your end number. Okay. All right. If you don't understand that, please read the part with arithmetic sequences and series. It says, what is the 9th term in the series? Okay, it's arithmetic. You're adding the same every single time. What's the 9th term? Okay, so whatever term you're trying to find, it's your previous term plus what? So how do I get from here to here? How do I get from here to here? -2. Okay, so if your first term was -7, your nth term would be -7 plus a -2 n minus 1 times. So this is your formula for whatever term you're trying to find. And they want the 9th term. So you're going to plug a 9 in. And you get -23. Do you have to do this? No. You go first term, second term, third term, fourth term, fifth term, sixth term, and you could just go and find the 9th term. That might actually even be easier. Okay. What are the first 4 terms in the geometric series? So your first term's a -3. So geometric's different. It's multiplication. They're telling you every time just multiply by 1.5. That's all that means. So the second term, -3 times 1.5 is -4.5. They're saying always take your previous term and multiply by 1.5. Negative 4.5 times 1.5 times 1.5. That's it. Okay, that's just saying whatever n term you're finding, take your n minus 1, that stands for previous, and multiply by 1.5. What is the fifth term of the geometric sequence with a second term of 33? All right, what is the fifth term? So first term, second term. They want to know the fifth term. Okay, so how do we get to the fifth term if your ratio is 1/3? So if we keep going, a third of 33 is 11. A third of 11 is 11 over 3. A third of 11 over 3 is 11 over 9. And you're like, how would you do that? Just multiply by a third every time, because your ratio is 1/3. So your answer is 11/9. Number 31, what is the sixth term in the geometric sequence? So we know the second term is 16. We don't know the third. We don't know the fourth, but we know the fifth is a fourth. So we have 1, 2, 3 jumps. So I start with 16 and I multiply by 1r, 2r, 3 r's, or r to the third, to get 1/4. Okay, or we could work backwards and say, how do I get from a fourth to 16? So I like that better. Let's start with a fourth and work backwards. How do I get to 16? I'll multiply both sides by 4. Get 64. And what's the cube root of 64? So you go down to math, you can do cube root, you can do 64. And you get 4. So I'd have to multiply by 4. I'd have to multiply by, doesn't make sense. 1, 2, 4 times 4 is 1, that's why. Multiply by 4, multiply by 4, okay? So they want to know the sixth term. Okay, well, if you keep going by dividing 4 this way, the sixth term is a 16th. So you have to figure out the common ratio and then find the sixth term. And if these are very confusing, if you're like, oh, if I know this example and there's an example just like it on the test, I can figure it out. Great. But if you're really struggling, you need to watch the video. Okay. What is the sum of the first 10 terms in the geometric sequence? You could figure out the first 10 terms, or you could use the formula. So we could do it either way. So you keep cutting it in half. You keep cutting it in half. You keep cutting it in half. And then you could add it up together, or you could use the formula. Now let me go grab the formula. Okay. So it's in your notes, but it's also in your textbook. Chapter 10. Hold on 1 second. It's the last one. I'm making a video. I'll be done in a second. All right. Right here. It doesn't matter which one. So if you want, you can use the top one. It really doesn't matter. Okay. So they want the sum of the first 10 terms, so put a 10 wherever you see n. Okay. All right. So the first 10 terms is your first term. Your common ratio is a half. And then you literally just put that into your calculator. You try to clean it up as much as you can. So 1/2 to the 10th, let's just do it this way. 2 to the 10th is this number. 2 over that. So you could just simplify it, make it 1 over 512. But you're timesing it by 2. So it's 4 minus 1 over 256. And it's about 3.996. So about 4, either one. So you just have to recognize it on your midterm. So I have one more left. What's up? So you add 5, you divide by 4 on both sides. You're going to get e to the negative 2x equals 2. If this form doesn't work for you, use log form. So change that into log form. That's incorrect. It would be you had to divide by 4. Now you divide by 4, put it in log form. Okay. Last one. They want you to put in 1, put in 2, put in 3, put in 4, all the way till 8. Okay? This is geometric because you're seeing you're multiplying by 1/3 every time. Just use your formula. So 1 through 8 is 8 terms. A sub 1 is your first term. So I plug in 1, what do I get? When you plug in 1, you're going to get 4 times 1, which is 4. So 4 minus 4 over 1 minus, well, what's your r? Your r is 1/3. You can put that all in a calculator if you want, or just try to clean it up as much as possible. And you could just do this. You could say 4 minus 4 times 1 divided by 3 to the 8th, enter, divided by 2/3. It's about 5.9 repeating, which is about 6. And that's it. Nothing. Easy.